Now, what we're going to go through next is specifically for students at my school who take the different chemistry courses, where we give them a handout to be able to explain how this handout works, so you can better be able to name and understand the different ions. Let's take a look. So what this part of this video is for is to help you get an introduction on how to use the green sheet for either Chem 3A or Chem 1A. Now, for the sheet, usually it's the color green, but right now I have just the regular normal version that we have as a PDF. How does this thing work? It looks very, very complicated and can be a little confusing if you are just looking at it for the first time. The one thing is I put start here because that's where you're going to start. Now, one thing you might notice is that it's in the shape of something we covered in previous videos, which is the T43 method, right? So it is in the exact same shape. So what do I mean there? Well, if you notice, we have borate, nitrate, and then silicate, right? That was blue. So that's our T. Then for the next column with phosphate and arsenate and sulfate and all these guys, this is our 4. So you can kind of roughly see my really bad drawing of a 4 here. And then chlorate is in the shape of a 3. So we have each of those different parts of the T43 method. Now, depending on which section you are in, you might be given this on your first test. But if you know how to use it and memorize it, then it'll make you faster rather than trying to search every little detail. Because if you only have like an hour to take a test, you don't want to be spending 2 to 3 minutes trying to search at all your references. You want to be quick. So we start here. The polyatomics, this is all your major 8 endings. So from here, the rest of the sheet goes with our modifiers. Okay, so the next 2 different little tables here, I refer to as a modifier, meaning if something does not quite match. So the first portion here, this column in the naming rules, this is all about if oxygens are changing. So if you have more oxygens, less oxygens, it's all about how are those different oxygens differing. So when we say we're starting, right, we have our 8 ending, and you can see that like ites is kind of like the first place most people will look at, which is 1 less than the 8s. If you have per, that means that you have 1 more than the 8s. Hypo is 1 less. So it's a modifier. So if your oxygens do not match, you want to look at this table for when the oxygens do not match. Now, what about the other ones? Well, sometimes you might have a hydrogen that could be part of your species as well. So that is a different kind of modifier. So if you have a hydrogen species that is on there, this is something that's very common in buffers and in biology. So if you're someone who has to take any of those things, which buffers will be covered at generally around acid-base chemistry, or if you have to take higher order chemistries, you will see that as well. Now, the only way the hydrogen works is based on the number of them. Essentially, it alters the charge, okay? So the charge changes. Now, for every single H plus you add, it's going to offset the charge by 1. So if I kind of zoom in here and we notice, okay, we have phosphate, which has a -3 charge. Now, if I add a single hydrogen here, we'll notice how the charge is now -2. So if we add 1 H, that all of a sudden changes that entire charge. Now, what about 2 hydrogens? Well, once again, you can see that, oh, if I do 2, now it's even more different. It's now -1. So every time you add a hydrogen, it offsets that charge by 1, 2, or 3, or 4, or however many you add, right? It's offsetting the charge. Now the naming changes too. As you can notice, when you add a hydrogen, we just say the word hydrogen in front. If we have 2 of them, it's dihydrogen. There's also other terminology too. One of the other ones that's common in biology is saying the word bi or bi for a hydrogen. So it's hydrogen, let's say, or let's say if you have sodium biphosphate or sodium hydrogen phosphate. So these are different ways for you to be able to understand that. Now, the other part is this part I call like your alternate starts. I don't really have a better way of writing that, but alternate meaning like if something doesn't match the 8s and you can't seem to figure out its charge and it doesn't match anything, this is where this guy comes in. It's essentially like all the leftovers that are not as important. Now, keep in mind, this is not every single polyatomic that you ever will come across, but this is generally the majority of the major ones that you'll see either in lab or in textbooks or in class. So there could be others that you've come across and you have to kind of, do some little research and see exactly what it is and how to name it and how to be familiar with it. But this is the general idea of one, how to use the T43 method and how to use your green sheet. I hope that this video helped you. Thank you so much for listening, and please come back for more. All right. See you all later. Bye now.